Welcome back to this video. In this video we'll see extended named ACL. So these are the requirements here, and we have the diagram here. So let's start talking about it one by one. So first one is deny 192.168.2.0 from accessing 1.3. So this network in the middle, uh, any of those devices should not access the HTTP service of 1.3. So this server here is 1.3 and none of these devices should not access that service. Next one is deny 3.0 from accessing 1.4 FTP service. So this network here on the right side, any of those devices from that network should not access the FTP service of 1.4, the server here. So we need to block that service. Next one, 3.1, this PC should not access the HTTP service of 1.3. Again, this server here. So this PC should not access the HTTP service. 2.0 should not access 1.4 DNS service. So any of these devices from this 2.0 network should not access 1.4 DNS service. 3.2, this server here should not ping this PC 1.1. Permit any, meaning other than these services here, everything else should go through, everything else should work. For example, 2.0 from accessing 1.3 HTTP service, but any of these devices from 2.0 can ping 1.3 because we are only denying the HTTP service of 1.3. Also, we can use the FTP service if that one is configured. We can also use the domain service if that one is configured. So you got the idea. Everything else should work other than these requirements. We must meet these requirements, but everything else should work. That's what permit any means, and we will also verify that. This one we'll talk about it as we configure. Now please listen very carefully. As for standard, we know that we need to identify the router closest to the destination. So in this case, our destination is one network. So the router that is closest to that would be this router here. So this would be our router in that scenario, and we need to configure ACL here and also find the interface that is closest to the destination, which would be the default gateway G000. That would be the interface we would apply the ACL. But now listen very carefully. For extended named or extended numbered, once again extended named or extended numbered ACL, we have an exception. This is only applies for extended, not for standard. Okay, I must stress that we cannot do this on standard. This is only for extended named or extended numbered. Okay, so this scenario 2.0, let's take the 3.0 example. So 3.0 from accessing 1.4. So here we have the 3.0 network. It should not access the 1.4 FTP service, which is its server. So in the normal scenario, the standard scenario, what we would do, we would configure the ACL here on this router, which means traffic go into the router and then leave this interface, right? Leave this interface, go out and come into this interface, and again from this S010 interface it will go out again and go into this S010, and then as it enters G000, that's where it will be blocked, right? So it's quite a journey, right? From here all the way here. It will still work. Uh, there is no question about it. We can make this work by doing on this router. It is just fine. There is no issues whatsoever. It will work. But think about the travel time. Think about what it is doing exactly. So when it goes like this, it's using the bandwidth. It's too much bandwidth of this network, right? We have a network in the middle, again another network, again in the WAN network here. So we are using too much bandwidth, which can impact the network performance. So we want to reduce as much as possible. Also, we are utilizing the router power, processing power. In this case also, we are maximizing its power every time a packet go through. So these are some of the negatives or the downside of this way we are configuring ACL by doing it on this router here. Okay, so the solution for this one is very simple. Instead of doing it on this router, okay, why don't we do it on this router? So for 3.0, 3.0, 3.1 and 3.2, we can configure it on this router, which means as traffic go in to this interface, right, go into this G000, the ACL is applied there at this interface, therefore it will deny here itself, right? It's not going any further, it will be blocked at this interface itself. So no travel time, no bandwidth usage, no router processing power utilization. Things of this nature can be simply avoided. So this is why we are doing it this way, right? So as traffic again come in to this interface, it will be blocked and it's not going any further. Same for 2.0, 2.0, and yeah, those two we can do it on this router, and as traffic go in to this interface here, G000, it will be blocked there itself. It doesn't have to travel across, right? So this is the way we should uh, configure extended. Again, I'm stressing extended, named, or it can be numbered. We can configure ACL at the source. It doesn't have to be at the destination. This right here is really applies for the standard ACL. But extended, you can do it at the source or you can do it at the destination. Like I said, by doing it on this router here, it will just work fine. Okay, no problem. But just some moments ago, what I said about bandwidth and router processing power utilization, uh, we can simply avoid those things by doing it on at the source level. Okay, this is why we're doing it like that. So what we'll do three nodes network on this router and two network on this router. Okay, and like I said, the interface would be the default gateway for both of these routers, and it will be the G000, right? It will be the G00 interface right here, this interface. And will it be in or out? Uh, it's very easy. The packets are leaving these devices, so that means it's coming into this interface. they are coming into this interface. But if I can put the ACL, I can apply the ACL here also on this interface S010, then it will change. That means it is going out, right? It's going out this way. So then it will be outbound. If I put it on the default gateway interface, it's in. The traffic is coming into this interface, and then it is going out. So I can do it on both interfaces if I want to, and we can make the ACL work just fine. Okay, doesn't have to be the default gateway. Here also the same concept is coming in to this default gateway interface, so it would be in. But I can also do it on this S010 interface right here. Then it will be out because traffic is going out. It's leaving that interface, right? So this is the concept. So let's start uh, configuring this. We'll start with this one. Uh, as always, I like to verify some things first of all. Uh, right now, we'll check the 2 dots. So let's go to 2.1. Let's see if we can access the HTTP service of 1.3. And we should access now. It is opening, so it is working. We'll go to here and try to access the FTP service of 1.4. FTP 192.168.1.4. It should ask for username and password. Is CISCO, and again CISCO, and password is also CISCO, and we are in. So it is also working. To exit here, we need to put quit. Okay. Next one, we'll check 3.1 from accessing HTTP service of 1.3. So the website should open 192.168.1.3. It should open because nothing is blocking right now, and it is opening. It's fine now. We cannot check the DNS, the domain service in packet tracer, so we'll skip that. 3.2 from pinging 1.1, so it should ping 1.1, ping 192.168.1.1, and it is pinging. So everything is working now. So let's start going through one by one. We'll start here. Neighbor conf t. So, as you might know already, extendeds always start with IP. So IP access list. Now we're doing named, so we can say, but first we need to say extended or standard. So we're doing extended, so extended, and we have to provide a name. We can simply say CISCO with all capital letters, and that's it. That's all we need to do on the first line, and we don't need to repeat this as we configure each statement. Okay, so this is fine right here with IP access list extended CISCO. Then we can deny each one of the service one by one. We don't need to repeat this IP access list extended CISCO like that as we do for standard access list. So deny, first one is what? Deny. We are denying 1.4 FTP service. Okay. Deny what? So FTP is the service of TCP. Okay. We have to know our protocol. So FTP is a service of TCP, which means we need to say deny TCP. Okay. Now what? This is a complete network, so we don't need to say host. We just simply put 192.168.3.0. Okay. And what? It's where the destination is a IP address. But since this being a network, we need to provide wildcard mask. Okay. So if I put a question mark, it's going to ask for wildcard bits. Okay. We must provide that. This is a class C network, so it will be the opposite of the default subnet mask. Default subnet mask is 255.255.255.0. So opposite would be 0.0.0.0.255. Now coming to the destination address, it's given as 1.4. So it is host, because it's an actual IP address, host 192.168.1.4 equal to, now this is a FTP service. So our FTP service is same as like that, so it will be just FTP. Okay, so this is it for the first statement, first rule. We are done with it. We can hit enter and it's done. If you notice, again deny, and then we need to say which protocol. FTP uses TCP, and so we need to say TCP, and we need to provide the source, which is 3.0. It's a complete network, which means we must provide the wildcard bits. Okay, and then we'll start with the destination. In this one, it's a IP address, actual IP address. So we need to say host, and then 192.168.1.4 equal to FTP, because FTP is the same like that. FTP, we can just put FTP. Next one is 3.1, from accessing 1.3 HTTP service. So deny. Again, we don't need to repeat IP access list anymore. For extended, we can just start giving the statements one by one after. So deny, it is a host, right? 3.1 is a host. So deny what? Deny the HTTP service. So we need to know the protocol again. So HTTP is a service of TCP, right? So deny TCP. Then we need to provide the source address, which is host 192.168.3.1, correct? And since this is a IP address for a device, we don't need to provide wildcard bit. We can straight away start with the destination. So the destination is an actual device also, 1.3. So we need to say host 192.168.1.3 equal to, now this is HTTP service. So HTTP, we need to say www. But let me show you something different. If I put a question mark there, usually we just put www and it's fine. But we can also put the port number. So for HTTP is 80, okay? And if I put 80 here, it will take that one also. So either you can put www or 80, okay? So let's put 80 this time. 80 and it will be fine, okay? You can either put www or put 80 there. Works just fine. So the last one is 3.2 from pinging 1.1. So deny. Ping is a service of ICMP, right? Ping is a service of ICMP. So deny ICMP. And then we can start with the source address. It is an actual device, an actual IP. So we need to say host 192.168.3.2. We don't need to provide wildcard bits because it's not a full network. We can start with the destination, which is 1.1 host 192.168.1.1. Now if you remember from last video, we know the ping uh, uses one other service with it, which is the trace route. So if I put equal to uh, ping, then what happens is it will still allow the trace route, okay, which is not serving the purpose. This PC or this device, this server here can still trace route this 1.1, which means this guy can see the IP address. This guy will see the IP address. So in order to block both ping and trace route, we say nothing here. We simply hit enter here and it will block both of them, both ping and trace route. Okay. And the last one is permit IP any. Okay. Don't forget IP, there is a IP in front of any. So permit IP any source to any destination. And we are done with the 3 network. Okay, now we need to move to the 2 network. We have 2 different rules we need to configure, which the first one is 2.0 from accessing 1.3 HTTP service. So let's save this first and go to our next router, which is this one. Table conf access list. Sorry, this is extended, so it starts with IP access list extended. We have given a Cisco. That's it. Okay, now we can start configuring these denial statements. So the first one is 2.0 from accessing 1.3 HTTP service. Deny. HTTP is a service of TCP, so it would be TCP, and it's a complete network, so we say 192.168.2.0. We need to provide the wildcard masks because it is a complete network. 0.0.0.255. Now we can move on to the destination part, which is 1.3. It's a device, so we need to say host 192.168.1.3 equal to again, if I put a question mark, I have 2 options. I can either put www or put the port number. Both will be fine. This time just put www and it's done. Next one, again the complete 2 network from accessing the 1.4 DNS service. Okay, so deny. DNS is a service of UDP, so deny UDP 192.168.2.0 0.0.0.255. Now the destination is host 192.168.1.4 equal to, now if I put a question mark, we can see we can either put domain or 53, port number 53 it uses. So I can either put domain or 53. So let's put 53 and it will take it. Now we just still need to put the permit statement here also, so that way other services can go through. So permit IP any. Okay. Now we need to start applying the ACL at the interface level. So in this router, we have decided to actually we haven't decided. We can either do it at this G000, or we can do it at this interface S010. So let's do it at S010 this time. So interface S010 IP access group Cisco. Okay, since it's S010 right here, right? So that means it's out, it's going out. Okay. Uh, it would, if it was G000, it would be coming in. Packets are coming into this interface. But since we are doing it here, it will be out. Okay. So that's what we're going to do. Cisco out. Save that. We need to do the same thing here on this one. So same concept, we can either do it on this interface or this S010. Let's do it at the default gateway interface on this one. So interface G00 IP access group Cisco out. Oh, sorry, in. Here it's in, right? The packets are coming into this interface, so it's in. So we have completed our ACL configurations, and we have also applied at the interfaces on both routers. So now it's time to check whether it's working or not. So we'll start with the 2.0. So we'll go to 2.1 and we'll try to access the HTTP service of 1.3 192.168.1.3, and it should block. It should not open the web page here. It should say something like request timeout. Meanwhile, we'll go to 1.4. Actually, next one is 3.0. So go to 3.1 and we'll try to access the 1.4 HTTP, FTP service. Last time we checked this and it was working. Now it should block. Let's check the other one. It says trying to connect. It's going to give us an error. So meanwhile, we'll check. We'll check 3.1 from accessing HTTP service of 1.3. so we need to wait a little bit. We'll go to 3.2, try to ping 1.1. Last time it was working, this time it should block. You can see destination host are reachable. So the 3.1 we checked earlier, it's blocking. It cannot access the FTP service. Also, web browser we checked initially, this was 2.1 trying to access 1.3. The first one is also blocking, so that one is also working. But 2.1 should be able to ping 1.3. So let's 192.168.1.3 ping 192.168.1.3, and we're getting the reply, so that is working. It should also access the FTP service, right? It should also access the FTP service, so we'll check that also. FTP 192.168.1.3, and it's working fine. Password is same, and we can access the FTP. So this is what it means by permit IP any. Other services should work. What else? 3.0 we already checked that. 1.4 it was blocking, but 3.1 or 3.2 should ping 1.4, right? So we'll check that one. Ping 192.168.1.4, and it is pinging, so that is also working. So our ACL is a success. Everything is working as it is. We have met these requirements, but other services are working fine. So I hope it helps somewhat. This is how you would do extended named ACL. Main takeaway from here is you don't have to do it at the destination. You don't have to configure at the destination like the standard. You can do it at the source. By doing it at the source, you are saving bandwidth, also not utilizing too much processing power of these routers. Both of these can uh, impact positively with the network performance by doing it this way. So hope it helps someone. Do practice it. In the next video we'll see some other concepts. Until then, stay tuned. Thank you. Good day.